So I'm Evans Hauser, and I work for a company called Apollo, and we build developer tools to help enable your data fetching needs in your web apps. And most of our tools are open source, so I work as an open source engineer on those tools. So the first question I have for y'all is, who here has heard about GraphQL? Who knows what it is? And who's used it? Cool. So this is a good introduction then to what GraphQL is. GraphQL is an API technology that enables you to fetch exactly the data you need from your client, from your server on your client. So you request a certain amount of data and you only get that data. It was open sourced by Facebook at React Europe in 2015 by Lee Byron, and it was actually used in production in Facebook's app on mobile since 2012. So what that ends up meaning is that it served about 300 billion requests per day. And that's impressive because we can see that it scales. In addition, GraphQL has grown in the past 3 years to be used by a huge variety of companies, including GitHub, New York Times, Airbnb, Yelp. And what's notable about GitHub and Yelp is they have a public API that you can use. We'll see a little bit about that in just a second. And the real question is that GraphQL answers is, what would an ideal API for apps look like? And for about the past 10 or so years, the answer has been REST. So what REST is you split up your data into different URLs. So like this would be GitHub API/search, and that would give you a search function, or /events, and that would give you all the events. So that's the state of the art up until GraphQL hit the scene. So let's see why REST runs into issues. First, with an example with the GitHub API. So this is a request for all of the repositories under the Apollo namespace. So what does that look like? We send the request to the server, and we get back some data. So what does that data really look like? Well, this was a query that we ran for all of our repositories with that same GET request, and this is what was returned. Now, this was about a year ago, so we see this is the example of overfetching. We just get a ton of data. This goes on for about a minute, so we can skip that. So then the next portion, once we've gotten all that data, say we want to display all of the contributors to all of Apollo GraphQL's main repositories. So that's Apollo Client, that's React Apollo, and Apollo iOS. So this is an example of extra round trips and actually underfetching for REST. So our first request was repos, and what we really wanted was not all the repositories. We wanted just the repository name and the contributors for those specific repositories. So that's where GitHub said, this is a problem. We need to dump REST for GraphQL. So the next question is, well, what is GraphQL really? And the problem that it solves is, why would we let the server decide what data to return? The real reality of REST is the server decides, you get the data, and that's what happens. As a client developer, I want the exact data that I need. So why can't we let clients specify the data needs, and the server tells me as the client what kind of data I can request? So let's do that. That's exactly what GraphQL does. It describes a schema on the server, and the client knows about that schema through a fetch and an introspection query. And we see that we get the capabilities from the schema, and then the query has the exact data shape that we need, requesting posts and title, and we get exactly that data. Then we can say, OK, I want the author, and that's what I'm going to get. I'm going to get the author and the first name. So I'm able to explore down into that schema and also see the schema as a contract between client and server. So it's not just about performance and data fetching exactly what you need. GraphQL was designed by Facebook from the start with developer experience in mind. So what does that really mean? Well, the schema is the contract between client and server. And what it does is provides a strongly typed, self-documenting contract. And I think the best way to illustrate this is with an example. So I'm going to show you a demo of GraphQL and actually use the, let's see if I can exit, and use, can you all see this, or do you need me to zoom in? Cool. So this is the GitHub API and the GraphQL v4 API. So we can request the repositories for Apollo GraphQL and the React Apollo repository. So say we want to explore and add more information to this query. In REST, we would have to go search our routes and search through API documentation, which is a real pain. So what GraphQL allows you to do is see immediately in your data fetching code what kinds of things you can request. So let's say I want a feed and to thank all of the companies that allow the contributors to contribute. So I'm going to add companies, and I'm going to run that request. So that's the main value proposition of GraphQL, is to be able to explore your data directly where it is, and we'll see how that translates into client applications in just a second. If you want to learn more about GraphQL itself and the specification and the options to mutate data and the semantics, you should check out graphql.org. For now, you have the understanding to at least start looking at what a GraphQL server looks like and how you go into production with a GraphQL server. And it's likely that the main thing that you'll want to do with this GraphQL server is integrate with your existing backends in order to create a well-typed and that contract that we talked about. And this ends up being a strength, not a weakness, as it might appear on the surface. And that's because GraphQL is the best way to build a technology is the best way to build a gateway because it allows you to wrap those existing backends with a common language. So the ideal, at the end of the day, is something like this, where all of your devices speak GraphQL, and that GraphQL API is able to fetch from your existing Rails application or Salesforce or your database or GitHub or whatever data fetching you need. And so that has the advantage of going through a centralized point and talking the same language. I think it's now important to give you the context on why that's so nice. So we've started to see that a lot more of these monolithic applications are being broke into microservices. And what a microservice is a portion of your backend that you want to be self-contained. So this is the example of a REST backend and in splitting microservices. So you might have a single microservices for all your contacts or for something. And each of those clients that you have, whether it's your web application, your native application, whether you're on React or React Native or Apollo or iOS or whatever it is, those have to know about each microservice separately. And there can be data dependencies between those microservices. So that's a waterfall loading. You might request the repositories from this microservice over here, and then the contributors are way over in this other microservice. So your client would have to know those data dependencies. And that's where an API gateway comes in. An API gateway is the idea that you take your REST requests and stick them in a common interface and make those REST requests come through in a single location. Similar to GraphQL, however, the issue with API gateways is that REST requests, for every new data requirement, such as adding data to your REST endpoint, you'll have to create a new endpoint for each of those. So the API gateway becomes a bottleneck for development as opposed to an enabler. And that's why GraphQL enables you to speak a single language. And the real power is when you want to add a piece of data or subtract a piece of data from your request, you can do that automatically. And the clients don't have to change. They don't have to know that you did this. They can actually do it themselves. They can request, I only want the posts. I don't want the author and the posts. So I think now we have enough background to actually go into what it's like to build a GraphQL server. So I'm going to show you Glitch. So Glitch is an online code sandbox. It's easy to it's open source. Anybody can use it. And I'm going to show you how to create your own GraphQL server in a couple lines of code. And the main thing is you have some imports, and your GraphQL server ends up, I'm going to be demoing Apollo server, and using this, creating a GraphQL layer to wrap the dog CEO API. It's a nice way to get dogs and breeds and pictures, and we'll see how that lines up to a front end. So the important thing to notice, let's see if we can zoom in, is the schema. So this is exactly as we saw in the slides, that you have entry points, so dogs and dog, and then on the front end you'll see in like graphical that you'll be able to get the ID, the breed, the display image, and any other information that you might need. And so now that you have specified the contract between client and server with a schema, you'll have to describe how you get the data that backs that contract. And the way you do that is with resolvers. So for the dogs, I'm going to fetch the result from my backend. So this can be ending up in any backend. This could be the GitHub API. This could be your database call. And then we return the dogs. And then we do that for every single resolver and field in the schema. So you have a one-to-one relationship between dogs and dogs, typedef to resolver. And then you return your GraphQL server and you listen to it. So then what does that look like on the client? How would they interact? So what Apollo server does is display a playground for you. So you're able to request the data from your endpoint that you created and see what kind of data I'm going to get. So we'll see the ID, the breed, and the display image, and with this query. So what does that look like on the front end with an actual request? So what we do is we put in our URL and to Apollo client, which this is using React Apollo, so we'll be using React elements. And then we look into, for this main page, the feed. And we see exactly the same query structure as we saw in our graphical. And then we're able to use that data from dogs just right here. So the exact same data shape that you use to request the data is the same shape that you use on the client. And that adds real power to GraphQL and provides an unparalleled client experience. So let's get back to the question of, OK, we have this idea of an API gateway that's perfect, and I can request exactly the data I need. OK, where do we put this API gateway? Where's the best place? There are 1,000 places you can deploy, because this is all JavaScript. We've seen client development, server development, it's all the same. You're using the same language. The front-end team can own this, no problem. So where do we go into production for a front-end team? That's the hard question. And so we saw some examples. We heard about some examples, excuse me. Platform as a service, you can deploy to Heroku. You can deploy to EC2. You can deploy to functions as a service. You can deploy to Azure Functions or Lambda. And then we heard about edge execution and things like Fly or Cloudflare. And this third option of edge execution is quite interesting, because you're able to cache partial results with this fetch function. So inside of your resolvers, you're able to say, OK, I make this fetch call, and then you have a dependent fetch call. And you're able to cache these independently at the edge and provide like the minimal latency and like minimal interface that a front end or product team needs to code to. And we're gonna see that in just a second. So what I have here is a project that is going to be an Apollo server deployed at the edge. So if we look at the code, we'll see that it's very similar to the code that we saw deployed on a most likely Heroku-esque or EC2 deployment. And what we do is instead of Apollo server, we use a variant that's Apollo server edge. So this ties into the service worker interface that most edge environments offer, such as Cloudflare or Fly or any other that offers edge deployments. Since Node Fetch uses window and browser globals, as we heard about in that V8 talk, we won't be able to use it, so we commented out. Most vendors offer their own fetch implementation. And then the rest of the code is the same. We still see the type defs, we still see the resolvers, and we still see our server creation. So let's see if we can deploy this. And come here and see if we can do it live. Cool. So then we're able to request from the edge and make sure that it works. And then I think the coolest part is changing our front end to use this edge. Let's see if I can copy the correct location. And then just drop it into our front end. Instead of using the platform as a service, we can just use the edge and directly fetch from there. So that's a super exciting development because you're able to lower the latency on your GraphQL requests. You're able to whole query cache with various cache control mechanisms. All of the fetch calls inside of your edge network could be cached on the CDN that is attached to those edge workers. So I find this a really exciting development in the deployment space because you're able to hit a GraphQL API so close to the client, and front-end teams are finally able to own a portion of back-endy or back-end for front-end infrastructure that's truly theirs. So that's what's exciting me now. And I'm curious if you have any questions. I work at Apollo. We're always hiring. You can follow me on Twitter. I'm Evans Hauser. I'd be happy to answer any questions. Please. Yeah, totally. So there are a couple options there. With Apollo Server, you can just set mocks true, and I can show you the documentation afterwards. And that's a really cool, powerful portion of GraphQL is you can use that sort of stubbing to say, I want this type always to resolve to this, or I want this object to resolve to this. And you're able to do that in the constructor of Apollo Server. In terms of like adapting your existing Swagger API, there's a client-side library, Apollo Link. I think it's Swagger. I can send it to you later.
So you would still use the Swagger?
Yeah, at least I see that as the frictionless way to adopt it incrementally. And then once you have it in GraphQL, you could start adopting more and more types in native GraphQL. There's a way to do schema stitching. So you have your schema for your Swagger API, and then you would have your brand new GraphQL definitions that are outside of Swagger and GraphQL schema first, essentially. And then you can stitch those together and resolve conflicts, and then on the front end display a single GraphQL API that would then delegate to each of these. Yeah. Sure. So an edge is a like compute environment that runs in like 150 locations around the world, and it's just a JavaScript environment that is like attached to essentially a CDN. So Cloudflare or Fly has a bunch of CDNs, and like normally it's just for setting headers or like changing the data slightly. This is a really interesting application because you can do like really granular caching and still have a nice API. It's a way of running JavaScript in like a CDN essentially. So like distributed around the globe. Yeah. So errors, there is a standard for how you display them to the client in terms of like what fields are exposed. So like in the root field, as the return, there's like a data field, and then there's an errors field. And then errors field contains like an array of errors objects that have paths that correspond to the resolver like waterfall. So like posts.authors would be the path. In addition to that, so I was showing you Apollo Server 2 beta. Will display a code, so like unauthorized, and that's something that the client can take action on, as opposed to just like message and location and the current like spec that's not super actionable on the client. In terms of back pressure, how do you mean? Totally. So you can throw an error there, and then you would probably have that status code say, hey, try back later. Like you can add to the HTTP. This would be like a feature on top of the beta. An HTTP header that says retry after. So that's the kind of thing that you would do. Yeah. So in terms of organizing your backend, I'm a client developer, so I'm much less familiar with it. So I would be lying if I said I had a good strategy for it. That's the kind of, I guess, limit of my knowledge. I'm happy to talk with you and Martin afterwards, because I would love to learn too. Not really. The resolvers are just functions. So you saw a fetch call in there, and you can essentially do what you want there. There is a library for batching across different resolvers to remove the issue of like an n+1, where you're like fetching posts and then like each post individually in the resolver. Yeah. And you can return partial data. So that's another advantage of GraphQL, is knowing where your result failed, and if your UI is resilient enough, you can display just the posts and not the authors and say, hey, request the authors later. The client will cache portions of a result. So, sure. So that was in this slide of like a I guess there were two different waterfalls we were talking about. We were talking about the resolver waterfall as well as a REST API's waterfall request. So the REST API is well described by this diagram, where a single request, for example, the request for repositories, then prompts you to say, OK, here are the repositories. I need to make more requests based on the first. So I get the repositories, then I have the repositories, and then I need to request the contributors. So that kind of waterfall of like, I need this data. OK, I'm at this plateau. I need more data. And so that's a waterfall there. And then the waterfall for resolvers is, the resolver model is, I have the dog CEO example. Can you read this? So the waterfall is, I have dogs, and it has a resolver, and it returns a dog. For each of the dogs, breed has a resolver, images has a resolver, and so I think the best way to describe it is dogs returns, and then the display image inside of dog is called. So the data from dogs is passed into the first object argument of the display image resolver, along with a couple other arguments. Like in GraphQL, there are arguments that you can pass into the query, and like the context, so something that lives across all resolvers, and like the information about the AST. Totally. So it's, I mean, it's open source, and it ends up being the Express GraphQL, which is another open source implementation, is similar in the way that it like accepts resolvers and accepts type definitions. And what was recently added, as in 2 years ago, was subscriptions. A year ago? I'm not familiar enough with the history. With subscriptions, so Apollo Server now adds that inside. So it used to be that it was a separate library. So for Apollo Server 2, we add that in. Error codes is a new feature that we're adding. And it adds like a health check endpoint. So ease of use, and ultimately that's I think what it comes down to whip up a quick GraphQL server is what's easiest to use, what's best documented, and there are some choices. Can I thank Martin for helping me out with the slides? I really appreciate it.
Good job.